Okay, we are going to take a look real quick at the boot process. This is actually in chapter 1. It's important information to understand from the standpoint of having to deal with troubleshooting. That's where this really comes in. Let's take a look at the how your computer boots. This is also important because any computer, right? Any computer is going to go through the same type of startup. And again, there's layers to what's going on with the hardware, to the firmware, to the OS, to the application. And knowing that that is happening is important for you to be able to go, this problem I think is down lower. This problem I think is with the app, right? Understanding that. That's the importance of the boot procedure. Right? You can go through your life and not know anything about the boot procedure. People can use their computers every day without knowing. What happens, though, is that if you want to be the expert in that area, you're going to have to know this information. And so this class is introducing you to it. So the power is applied to the CPU. So boom, you hit the power switch. And then, so right, general steps, because every one of these devices can be slightly different. So the CPU and the hardware components get that. The CPU starts up. The CPU executes the firmware and the startup routines that are basically encoded in the chips, especially the UEFI and BIOS. The operating system is located by the firmware. So basically the CPU is like, hey, I can get going, and what I'm supposed to do first is execute this code that's sitting in the firmware. Boom, execute the code. The firmware then is going to do a bunch of stuff, and one of those things is finally to locate the OS, which should be in a particular boot sector. And then the OS is loaded into RAM, and the OS processes all the services and processes that need to start. So the firmware is code that's basically, or programming that's basically burnt in, as we like to call it, to a chip that cannot be modified. And again, covered this in other courses, but basically what you're doing at that point is saying, I have USB 3.2 on my computer. How does the computer know that? And how does the computer know how to deal with it? Well, that's not really part of the operating system. What that's a part of is that chip has firmware built into it, telling it, this is how I deal with this port that's on the back of the computer, and this is the data channels I use to get the information to the CPU and blah, blah, blah. That's encoded into the firmware, meaning that it's not easily changed. It's firm, right? It's not solidware. It's firm, meaning most of the time you cannot change it, but there are some situations where you can. Non-volatile memory, right? That memory that maintains its contents when the power is applied to the system. So meaning volatile, turn off the power, it's gone. Non-volatile, turn off the power, it's still there. So there's part of your BIOS, your UEFI, that basically has this EEPROM. It's a read-only memory in older systems. And you typically have to go through a flash process in order to update that stuff. But it can be updated, hence firmware. So for instance, whatever board maker you bought initially didn't realize that they had a bug in their, again, we'll say USB 3.2 stuff. Oops. So later on, they figure that out and they go, okay, well, we can fix that through a firmware update or a BIOS update. And there it is. You can now go download it, and you can go through a process that's going to flash this memory to the new stuff that fixes that problem. And once that's burnt in and done, it's non-volatile. It doesn't matter if you turn the system off. It'll always remember that that's been fixed. It's been done. So when your system boots up, it's going to boot this basic input-output system, and that's part of the UEFI. So they say BIOS or UEFI in newer systems. Well, UEFI has been a part of our life now for probably 10 years or more. I don't know. And BIOS is the old term. But the truth of the matter is that the UEFI has some of this BIOS config and information in it. And the UEFI is now doing more than what it once did. And so you'll hear these terms almost interchangeably a lot. Oh, that's in the UEFI, that's in the BIOS, right? What do they mean? They actually meant the same thing. go into where all the settings are that is in this non-volatile memory and take a look at what's going on, right? So the firmware contains a bootstrap program, and that loads the bootloader. So part of the OS, again, when it gave us that general information about what it's doing here, is it goes, oh, I'm supposed to go over to this little tiny place on this storage device, and that'll get me going. And that's the bootstrap, a bootloader program. And basically that bootstrap or that bootloader knows how to proceed at that point, right? It knows how, this is how we're going to load the OS. All right, so basic input, I already talked about that. So there's lots of different things that are in the BIOS. Power on self-test post happens there and locates and loads the OS. So we talked about that. The part that's changeable is actually known as the CMOS. So that's complementary metal oxide semiconductor, and that has been its name for the beginnings, all the way back to the 70s. And so anytime you can go into the BIOS and it's like, here's the date, right? I'm going to turn on the virtual machine settings. It's not on. I'm going to turn off this SATA port. I'm going to turn on this SATA port, right? All that stuff that you can change back and forth is actually stored in a specific location called the CMOS. And you have a battery on the system that provides power to the CMOS to make sure that it doesn't get erased. So when the battery goes out, then you get beep, beep, oh, I can't remember stuff. And it usually goes through an autos, right? It finds everything and boots anyway. But it's annoying. It's annoying when that battery runs out. All right, let's see. Oh, these are the processes and services within Windows. And that's once the OS really starts to kick in. So it goes through that bootloader. There's several ways, and this is different per OS. So there's several ways or several things that they're doing in this process as they're going through and booting the system. And as it said, within Windows, it's going to look and say, what are the services that I'm running? What processes need to be running? And this is actually where you can find those within Windows. As a matter of fact, I'll just pull that up. That's the same screen, except you can actually read it, right? And I can see the services. I can come over here and see what they are. So, that's kind of the stuff that we'll be digging into later on. We're not going to deal with that now. All right, couple of terms, and we're almost finished. The kernel mode is a CPU mode in which the process has unrestricted access to the computer hardware and has access to privileged CPU instructions, this kernel mode. So you can kind of tell where they're getting at here. What they're getting at is we probably don't want the user with this kind of access because they might mess something up, or maybe they're trying to steal information, but usually they might mess something up. And way back in the old days, you'd have a machine and it's like, oh, it's locked. It's totally locked. It's totally locked. And it really wasn't because the user was doing anything. It was because somebody misprogrammed something, but that would still be considered the user mode where the program is, it's doing something it shouldn't. It just locks the machine up. There's nothing you can do except power it off, turn it back on. User mode, right? That's CPU mode, which the process can only access memory locations located by the OS, must ask the OS to access it on its behalf, and can't execute privileged CPU instructions. So this is a more protected mode that allows basically for, oh, whoa, that program just crashed. Well, it didn't really, right? I'm acting, but your whole computer didn't lock up though. And so it just, boom, whoa, we're just shut down. And usually there's an error message. And that basically, that user mode is to protect against those kinds of, whoa, we're locked up and my whole system doesn't work. We don't want that, right? We don't want that. Some really good information that you should look at this portion. This unit, we're about halfway through, and it gives you some information specifically about the different topics that we've looked at. So again, any questions, then please let me know. Let's get them answered. And thanks for watching.